Hi, welcome to Founded Pi videos. This is DC here. In this video, I'm going to discuss about passwords used in AT88SC153 secure memory card. Throughout the document, you will come across the word secure code. If you have seen my earlier videos on the AT88SC102 card, it was called as a transport code. The secure code is set by the chip manufacturer and it is passed on to the card manufacturer. So during the transit, the chip is kept secure because of this secure code. Once the card is manufactured, the card manufacturer can change the secure code and pass on to the card issuer. So during this transit, the card will be secured by or protected by this secure code. There are 4 passwords and 2 are for read password called read 0 and read 1, and 2 are for the write passwords called write 0 and write 1. The write 1 password is also called as a secure code as long as the personalization fuse is not blown. So it is the same password having 2 different names. Before it is personalized, it's called a secure code. After it is personalized, this password is referred to as the write 1 password. So with this background, I'm going to show you how to do the password change and all the password related activities. You can see here this software is in version 1.9.1 and I've connected my AT88U reader with a brand new SC153 secure card. So I would like to show some of the changes that has gone in this release. Now we have seen this screen in the previous videos. However, some new sections have been added. It also means this screen will show you some of the features that were not mentioned in my previous videos. In all the 3 user zone tabs, I have got this write lock section. So as the name says, the first 7 bytes of each of the user zone can be locked from further writing, and I'm going to show in my later videos how to do this lock. It is only the first 8 bytes that can be locked. And also I have provided a small feature here where you can use to populate the 64 bytes of user data. Without this, you will be end up typing a lot. Say if I have to set this to the hex AB, you just type AB and click on fill. So this fills up all the 64 bytes. Now in the fabrication section, before we had a fuse section here that has been removed, and there's no chain identification section as well as secret. Now this is the new section that is introduced in version 9.1. So here the fuses section is moved from fabrication to here. Now after going through the documentation again, the way the fuses are blown is something different from what the documentation, the ACR30 documentation says. So that's the reason why this has been reorganized. And this section called authentication, which is used to authenticate the reader and the card, is also introduced, and this probably I'll be covering in my later videos as well. So since this video is all about the password, so let's go and see how the password works. Now when you hit this read entire tag, this password code is populated with the value 06, and this is not the correct password. So when I bought this card, I was given the default secure code by the seller of this card. So I have modified that, and my new secure code is all set to DC, DC, DC. Now if I click verify, you can see that this command is explained in the AT88U documentation. It's called as a verify password. If you look at here, this is the command that's sent to the reader. So there are 3 bytes for the password values. It's a 24-bit password, and because there are 4 passwords and only one single command, the command lets you specify which password you're trying to verify. So this is set in the parameter P2 of this APDU. So this is all 5 zeros followed by RP. So R will be 0 for write password and 1 is for read password, and the next bit, the password number, is either a 0 or a 1. So if you are verifying the read password 0, you'll end up setting R is equal to 0 and P is equal to 0, that's 0, 0. If you want to verify the write password 1, it will be R is equal to, sorry, I was just wrong in it, is for read password it will be R is equal to 1. For write password it will be R is equal to 0 and the P is equal to 1, so 0, 1. So here also it's mentioned that the value 0, 1, which is the write password 1, is also referred to as a secure code. If you see the command that's sent here, so I'm passing 0, 1, which is the right one, secure code, so followed by the 3 bytes of the password. Now we know that you always get kind of a 90 followed by some number. Now this number, the documentation says, can be used to know if the password verification is right or wrong. It says if it is FF, indicates verification is correct. If it is 0, indicates the password is locked. Any other number tells you how many more password attempts are left. Now once the password is verified, if I hit this read entire tag now, you can see that the passwords of all the remaining section, that is all the remaining password, we are able to read. In fact, if you go and see this the secret code, the value of the secret is also visible, as well as anything that is protected by the password is now readable. So I'm going to show you how this card behaves when the password is wrong. For that I'm going to reactivate. Every time you hit the select card, what AT88U does is it just powers down first and again powers on, so that basically resets the card, and any authentication or pass verification had before will be lost. So select. So I'm going to verify with a wrong password. I'm going to try with all FFs, verify. You can see that the password attempt counter for this secure code is changed to 011, and this pattern of 4 bits repeats here as well. So the documentation says by default the number of wrong password is set to 4. There is a command or feature where you can make the number of wrong password attempt to 8, which I'm going to show in my later part of the video. So here 0 means I have already used 1 attempt and I have got remaining 3 chances before the card get permanently locked. So assume that we are trying to guess this password, and every time you verify with the wrong password, so you'll be using away the 4 bits, the few bits at the beginning. So I'm going to try. So to be very careful when you try this, because after 4 wrong passwords it's going to lock and you cannot verify the password again. Now I can't go beyond this because I'll lose this card. So my password is DC, all DCs. So when you verify, and also if you look at this command here as well, look at this response here. In the first, this was the first wrong verify password. You got this EE. When you convert this EE to binary, you got 0111. Next time you got CC, and next time you got 88. So which it is, when you convert this hexadecimal to binary, you have to show that in a reverse bit order. I'm going to hit verify. So this time I got all FFs, so it's the password is right. Now once the password is right, the pack will be set to FFs. Now I can read. If you hit this, if you try to read any of these passwords, you will get the password. So now we know all these write 0, read 1 passwords are all FFFs. So after this secure code is verified, you can modify all the data so that are available only after this verification of the secure code. Now I can go and change the secret. The changing of the seed and the passwords, most of the time these are done before the personalization. So however, you can see what kind of commands are used during this write operations. Assume that if you try to read here, now the same thing, the verification works very similar to what we have just seen. Say for example I want to verify the write 0, so I'm going to try with the wrong password. Say verify. It's very similar. We have already used the first in our wrong password counter, so you keep guessing, verify second time, the third time. Now if you try to do this again, the write 0 password get locked permanently. It becomes a non-usable. Even when this is locked permanently, when the value of the pack is all set to zeros, so you cannot use this write 0 password at all. So any user zone access right that depends on write 0 will never work. So I know the password for this tag is all FFs. Verify, you got back. So this works in a very similar to this. Only thing, you would make sure that you understand this command structure. So I'm going to modify all these passwords. So first I'm going to verify with my secure code. It's done, and I want to keep my secure code it says DC. Then I'm going to write and change the password for write 0. So for it's easy to remember, I'm going to set them all to A0s, write, and if you try to read, so the write is successful. I'm going to set this as A1. I want to set this as a B0, write, try to read. Okay, this I'm going to set as B1, write, read is fine. I can also change this to A1. So now I've changed my password. Oh no, sorry, I clicked on verify, it's wrong. So I have to go back and first verify, then I'm going to modify that to A1. So I'm going to make a note of these passwords now. I'm going to try my new password, so make sure that it's right. Go to passwords, A1. Now my password is right. So you may be wondering how it is possible to modify the user zone 0, 1 and 2 without any password verification. So it is because of the setting I got in this tag. Now I got this card activated. I have not authenticated it. I'm going to modify the user zone. I'm going to set this last byte as 0, right? If you try to read again, you can see that the read is successful with the value last byte as 000. So there is all these three user zones are controlled by the access rights, which is specified in the fabrication zone, and AR0 corresponds to user zone 0, AR1 corresponds to user zone 1, and actually there is some typo error here, AR1 and AR2. And if this is the default value of this access rights with the my tag, so I'm not sure whether this is the default in every tag you buy. So the first bit is called WPE. If you look at the documentation, it says it's called write password enable. If this is set to 0, the user is required to verify with the right password. If it is 1, then the password verification is disabled. So it is because of this bit we are able to write to all the three user zones without any verification. Likewise, I'm going to have a separate video, because this section, the access threads, is very important. I'm going to spend this in detail probably in my future videos. In the fuses section, this is the value of the fuse. So as you can see here, the fabrication fuse is blown. I still have the card manufacturer fuse and the personalization fuse, which are intact or not blown. And with this settings, if you see the documentation, so we have to understand how this card behaves. So when for different values of the fuses, so you have to refer to this column FAB is equal to 0. So here you'll come to know all the things you can do and cannot do when the fab fuse is blown. And you can see here the fabrication zone is always readable. If you look at this bit, read is always free and the write is forbidden, except for some of these zones. You cannot change the fabrication zone or most of the data fabrication zone. You can read, the card manufacturer code can be read, but in order to modify, you need verification from the secure code. The access register you can read anytime, but to modify, you need a secure code. The memory test zone, which is always both readable and writable. The identification zone can be read anytime, but you have to verify with secure code to write. So likewise, the secret code you cannot read as well as write without the secure code. The password also, we have seen the password. So only after the verification with secure code you are able to read the password. If you look at the value of the packs, you can read anytime, but you cannot write without a password verification. So while the card is in this state, like with the FAB is equal to 0, the password is called as a secure code. The user zone, the read and write access, it all depends on the value of the access register. Now I'm going to show you about the secret section here. The secret section is used in the authentication protocol. Now what the documentation says is you cannot read. So after the secure code verification, I can read the value of the secret code. So here I'm still not probably verified. If you try to read, the read is not successful. You get the secret code also This is what you get when you try to read without any verification of password. It's all 06. I'm not sure why it is 06 but not all zeros. I'm going to verify first with my, remember this is A1 now, all A1s, verify. This verified. If I go and hit the secret, now this is the value of the seed or the GC with probably when you buy a new card, all the values are set FFs. Nothing more or less we have covered with what the tag, how the tag behaves when the fab is equal to 0. The only thing what you can do here is probably set the manufacturer code where I can write. Now the chip manufacturer, probably he will put the code of his customer or the card manufacturer. It's over here to read. So we are already verified. So I'm going to set this as same thing as DC, say write. Now try to read it. Read is so successful, so we are able to modify the card manufacturer code after the verification of the security code, secure code. Now to keep one thing in mind here, which is very important. Now the card is in a state where the secure code is verified. I'm going to verify, I'm going to use, or I'm going to verify with the right password 0. Now the tag is no more verified with the secure code, but it's verified with the right code. If I try to read the value of this seed, you're not able to read it. So in order to read, you have to have the secure code verification. What I would like to mention here is the card remembers only the last password verification. So if you are verified with the secure code, after that you verified with the read 0 verification code, the card remembers only as a read 0 verified state. It doesn't know anything about the secure code. Now again, if I go and try to modify this or read is always possible. Go and modify the write. Now if you try to read it, that the write was not successful. You're able to still read the old value.